This is could be a short PowerPoint on how humans learn, uh, and it's based on some current research. But this is how humans learn. Most people have seen this. It's basically what type of learner are you? And there's active learning. There's visual, sequential, sensing. But here's the issue: if you go and do the research, let me see if there are some studies done to see if this is really true. And the evidence doesn't support it. Basically, read this, pause this, and read what each one is, and see if it doesn't apply to you a little bit. And Harvard, Yale, basically all the Ivy League schools, Oxford, the Sorbonne. Anybody that can look at the data and actually looks at it and crunches the numbers knows that this isn't the way humans really learn. So how do we learn? When I was in college, my classes typically look like the next slide. It's painful to watch, so you might want to skip ahead a bit. But see if this doesn't look familiar.
And we start off and we talk about, this is really nice, okay. Fluid, okay. The definition, first of all, of a fluid. The official definition in chapter 1. Put that down. It's a substance that deforms continuously when acted upon by a shearing stress of any magnitude.
The trouble is that's not how you learn. Lecturing is one of the worst ways to do it. And we'll get into some studies later. But this is how we typically learn: small social groups working together. We'll get into that also. But you kind of need lectures, right? So how long should a lecture last? It's good to introduce some new material, get people into the books, get them started. Well, it depends. If they're really interested in the subject, you can probably do it for an hour, hour and a half. But the finish, say, if you're trying to learn something totally new, you got about 42 minutes, and then everybody checks out. To include the lecturer, generally, a lot of times, 42 minutes. Uh, but basically, if there's no interaction and it's a new material, research says about 10 to 15 minutes. And don't take my word for it. Go look it up yourself. I did go and benchmark Western Michigan and West Point on the Zoom classes during the pandemic. They had the same as my college, little interaction, and only a few students interacted. Most people just sat there and listened. And I said listen, but most people just sat there. I doubt if they were listening. They just wanted to get to the homework or the test, and that's where they're going to figure it out, not through that lecture. 2014, a study found that undergraduates in traditional stand and deliver lectures are 1.5 times more likely to fail than students in what's called active learning. And I think with Zoom, it's probably even higher, that 1.5, or a lot of them, like I did, lowered our standards a little bit. Turns out we're hardwired to learn a certain way. So how is that? A guy named Thomas Landauer did an interesting study. He wanted to know how much our brains are capable of holding, and put in terms of gigabytes, like a computer. So what he did is, well, I'll go over here, but he says, in a lifetime, how much information do adult memories contain? Okay, this is what he did. Then he basically just fed some people information and just saw how long they could retain it and how much they could retain. So this is where you guess. How many gigabytes does the average brain hold? Pause it, think about it, and make your guess. Turns out that humans only remember 1 GB. And how much is a gigabyte? I paid $88 is all I paid, and I got 64 gigabytes in this little thumb drive. Yeah, I can hold more in my thumb than I can in my brain.
At this point, some of you guys might be freaking out a little bit, feeling a little bit concerned. After all, we all think it's the most important thing in the world to know a lot and have great memories. But really, this is a misconception. We do not have to know a lot because we're not made to think on our own. It's natural to think about thinking as what happens between your ears, but that's not where the magic really happens. This video comes from a psychologist by the name of Michael Tomasello and his colleagues. They study human children's cognitive abilities in comparison to other animals like chimpanzees. The goal is to understand what really makes us special. What abilities do we excel at that other animals just cannot master? You see how easily this young child reads the mind of the experimenter and then figures out how to coordinate his behavior to achieve the goal. He even makes eye contact at the end, as if to say, "I've got your back, man." This is so natural to us that it seems like nothing, but it's actually incredibly difficult to design a cognitive system that's capable of collaboration. This is really the secret to our success. It's what separates us from all other thinking creatures. Chimpanzees routinely fail at tasks that require sharing knowledge and working together to pursue goals, tasks that young children master with ease. Now, for me, this realization was a major wake-up call. It really changed my perspective on the nature of the mind. I'm a cognitive scientist. I'm used to studying how individuals make decisions or solve problems in isolation. But thinking is a social process. Rather than happening inside your head, it emerges from your interactions with those around you. People are a little more like bees than we often realize. In a beehive, you have an incredibly complex cluster of behaviors that is achieved despite no individual being responsible for it all. Food is collected and stored, the hive is protected from intruders, genetic diversity is introduced. The key is specialization. Each individual does its own little part, and the complexity emerges. The same is true of people. On our own, none of us knows all that much. We don't have to. We each have our own little slice of expertise, and our minds are built to collaborate and to share knowledge, which allows us to pursue incredibly complex goals when none of us has anything approaching the knowledge to understand it all.
So let's talk a little bit about active learning. So what we're doing is asking the students to participate in the learning process, make them think, discuss, investigate, create. You can't do this in a lecture. You just sit there and take it. In classrooms like this, students may ask practice skills, solve problems, struggle with complex questions, propose solutions, explain their ideas, right, and write in a discussion. These are especially effective for students learning when compared to classes primarily consisting of lecturing, right? Go back and look at the two slides. Go look at the guy who's writing the definition of fluid dynamics versus a bunch of students sitting around a computer working together solving problems. Which one do you think is learning the most? Again, I just want to highlight, research indicates that active learning are effective for student learning, especially when you compare them to the lecturing, just standing there and taking it. In fact, if you want to remember something from a lecture, you generally have to hear it about 6 times. So why is it better? Well, it reinforces material concepts and the skills. You get immediate feedback because they're actually doing an activity, which they can get, whereas a lecture, you take it home and then read about it the next day. They have to think, talk about, and process course material. That's why it has to be in a group, right? You can't talk if you're standing by yourself, right? You can't have a discussion. And it creates a connection to the material, right? And that actually motivates the desire to learn. And it also lets them practice with collaboration and group work, right? That's a big one right there. And it also builds self-esteem. People feel better about themselves when they're actually creating and doing something as opposed to just sitting there and being told something. And it's a sense of community in the classroom and also outside the classroom. Anytime somebody's learning through this active learning, it's building community. And collaborative learning, right? This is peer-to-peer, maybe a little bit larger groups. But what you do involve working in pairs and small groups to discuss concepts or find solutions to the problems, right? It's not one guy on his own. It's a bunch of people together. 2 or 3 heads are always better than one's the idea here. And it's found that through peer instruction, students teach each other by addressing misunderstandings and clarifying misconceptions. So what does that mean? Well, if you're going to teach the subject, if you talk about it and try to tell it to somebody else, you're learning it better yourself, getting more depth. You know, lecturing was about 6 times. You're looking about 2, maybe 3 times if you do collaborative learnings. That's all you need to see the material. Research, and that research came from Cornell about collaborative learning. It gets a deeper learning. In other words, it sticks with you a little bit better, whatever you learned. So some of the benefits they found directly, it's a higher level of thinking, right? Oral communication, self-management, and leadership skills, right? You don't do any of that when you're just sitting in a chair listening to somebody talk. And a student-faculty interaction, if you have a small group and you still have a faculty there, they can ask the instructor questions. So you get better interaction and interactions that's more meaningful to the student. And it also increases retention, self-esteem, and responsibility. People like it when you have a chance to express yourself, participate in the learning. And you get diverse perspectives, right? Get new ideas, not just whatever the instructor tells you, right? And this is the way it happens in real life, both in a social and in employment situations. Classrooms are just very artificial. Now here's the problem. You sit alone at the computer and whatever is coming on that computer doesn't stick, right? You're just sitting there. Not the best way to learn. I'm going to let Stephen Sloman talk a little bit about social learning. In other words, they learn a whole new concept. And if you took any of my stats class, you know that his results are significant. But this is Stephen Sloman.
Turns out Americans aren't as knowledgeable as they think they are. About 25% of Americans don't know that the Earth revolves around the sun. I believe the Earth revolves around the sun and that the sun doesn't revolve around the Earth. Don't ask me how I know that, right? Because I've never perceived it directly. I sort of take it on faith, and yet I call it knowledge. And this isn't just a modern phenomenon either. So in 1943, only 25% of college freshmen knew that Abraham Lincoln was president during the Civil War. Oklahoma State did a survey, and its Department of Agricultural Economics did a survey a few years ago, and they found that over 80% of Americans support the idea that GMO, genetically modified foods, should be labeled as such. They should be labeled as produced with genetic engineering. This seems like a perfectly reasonable thing to support, until you find out that they also thought that foods containing DNA should have mandatory labels. So it makes you wonder what the thinking process was that led them to the first conclusion. Just in case you're unaware, it's hard to find foods that don't contain DNA. This feeling that we understand things better than we do has become a real problem, I think, right? And it explains the heat and vociferousness of some of the debate that we see in politics. This has been observed for years. This is a quote: "It is better to remain silent at the risk of being thought a fool than to talk and remove all doubt of it." Churchill said the best argument against democracy is a 5-minute conversation with the average voter. And another of your countrymen, Bertrand Russell, pointed out that this failure of understanding is one of the causes of extremism. The opinions that are held with passion are always those for which no good ground exists. What is it about people that causes them to think they understand things better than they do? And the answer I'd like to suggest is that we suffer from it because we fail to distinguish what other people know from what we know. So other people understand cap and trade in carbon emissions. I may not, but the fact that other people do makes me feel like I do. It's a kind of knowledge conflation. We conflate other people's knowledge with ours. And as a result, when we're thinking about the mind, instead of thinking about it as something that happens between the ears, we should think about it as something that happens within a community, because we depend on each other's knowledge to a great extent. Here's a little study I did with a student at Brown named Nat Rabb, which shows how knowing that other people understand things make us feel like we understand. So in this experiment, we invented the phenomenon of glowing rocks, and we told people that the scientists who discovered them have not yet explained them. They don't yet understand how these glowing rocks work. How well do you understand them? And people gave the natural response. I don't understand them at all, because they don't. They were just introduced to them. Consider this other condition. Everything's the same, but in this case, we say, the scientists have thoroughly explained how these growing rocks work. They fully understand how they work. How well do you understand how they work? And here are the data. So the first thing to notice is nobody has a great sense of understanding here on a 1 to 7 scale. In one condition, when the scientists don't understand, their judgments aren't much higher than 1, right? But when the scientists do understand, their judgments are almost twice as large, right? It's just a little bump. They're not saying, oh, I fully understand glowing rocks, but they have a sense of understanding that they didn't have before. Imagine if 100 people around you are saying, I understand why Hillary is crooked, or I understand how the economy will benefit if Britain leaves the European Union. Presumably, if you have all of those people and people close to you, you're going to have a sense of understanding yourself. I don't think the answer to this problem is education, right? Or it's not simply education. What I'm talking about is a basic aspect of human psychology, something that's true of Americans and British people and liberals and conservatives, that's true of everyone. And we can't just educate our way out of it. There are other kinds of things that we can think about. So in the world of financial decision making, there's a lot of evidence that if you want to get people to, say, save for their retirement, which most people think is a good idea, the way to do it is not to teach them about the benefits of saving, but rather at the point of decision to give them the requisite information to get them to invest. This is called just-in-time education. There are important implications for leadership here. The value of a leader is proportional to their ability to use the community to find solutions to problems. So ignorance may be bliss. And the truth is, illusions can be pretty nice too, right? Voltaire said that. Illusions are the first of all pleasures. But they can be problematic. They're problematic when my sense of understanding, like my sense of understanding who to vote for, is based on the understanding of the people around me, and their sense of understanding is based on the understanding of the people around them, so that in essence, there's no real understanding, and we're all voting based on a house of cards. I love the way Robert Armstrong put this in the Financial Times. We imagine ourselves as rugged cognitive individualists, growing our own intellectual food and living in mental houses built with our own hands. This is a dangerous error.
Let's try a little bit of active learning. You're sitting at the computer, or you're close to a computer. What I want to know is, what is the population of the capital of Greenland? Go ahead and take some time and see what you come up with. Take a few seconds and think about what else you learned about Greenland. So what else did you learn, right? Besides the population, right? Did you figure out the name of the capital? Well, yeah, did weather the capital, social life in Greenland, ethnicity of the population, anything else? See, if I would have just stood up here and told you that Nuuk is the capital of Greenland, you would only know that the capital of Greenland is Nuuk. You wouldn't know any of these other details, or potentially other details. See how much different that is? That's the way people learn. So what do? Do it the way you're hardwired. Get into small groups and learn. And if that's not possible, I mean, you got technology now. You got FaceTime, Zoom, YouTube, Facebook, whatever you can. But don't get into these big Zoom meetings where there's 15, 20 people. You're not going to learn that way. You want small meetings, 3, 4 people at the most, right? That's the way you can learn. You can still connect, but it's got to be over the. You can use technology, right? Not the best way. Face-to-face is still the best way. I want to make that clear. But we're hardwired to learn in small groups, collaborating.